Okay, I'm Sebastian. I'm working here as a PhD student at the Scientific Computing Institute, and I will talk about cross-compilation and emulation in LLVM, mostly in with respect to testing patches and getting your patches accepted. So, bit of background. So recently I was working on an extension to LLVM X-ray, which is a profiling system integrated in X-ray. Uh, and this extension I built enables shared library instrumentation on x86. This is not what this talk is about. But so I was upstreaming this extension, and I had some issues with testing it properly because there are some challenges in that. Well, the patch I introduced touched many different project parts, so it could break everything basically from the CMake build system to target specific libraries and everything. It had target specific code, so it may work from one target and not the other, so just testing on your own host system is not enough. And also there's runtime components that need to actually execute on different targets to be tested thoroughly. So all of these features made it quite difficult to comprehensively test. However, initially this feature was limited to x86, and the pre-commit tests succeeded. So, and if it works on my local machine, then of course it should work everywhere else. But so this is what happens after after the patch was accepted. There were a couple of failures on PowerPC, ARM, and ARM64, which caused us to revert the patch, and we had to investigate how this all happened. And this is why I want to talk about my experience on how to avoid this, hopefully. So this will be part experience report of a first-time contributor to LLVM, and how to kind of navigate the buildbots and testing. And also a brief introduction to LLVM's pre- and post-commit continuous integration pipelines, and a collection of useful resources for cross-compilation and also emulation, so that if somebody is in the same situation, they may look at the slides and maybe have some ideas how to do things properly. By the way, I'm not an expert on any of these topics, so if you have any input or any corrections, please just interrupt me. Cool. So short introduction on the buildbots. So LLVM has various stages of CI and buildbots for testing new patches. There is quite rudimentary pre-commit testing, where there's just an x86 build on Linux and Windows running on new and changed pull requests on GitHub. And this is basically to catch like very basic, let's say, compile errors and stuff that always breaks. Yeah. That's good. That's good to know. I didn't know that. Yeah, but also these bots are also not always running perfectly, so they may also be broken. So yeah, it's not always the best indicator of success for your patch if they work or don't work. Then there's the sort of official form of LLVM buildbots, which is a large collection of bots that tests all the patches that have been accepted. So basically just pulls from main whenever a new commit is there. And these bots test a variety of targets built from configuration and different test suites. Yeah, and quite cool is they report back to the GitHub API, so you directly see in your pull request if something has gone wrong. And here's a URL where you can mirror all of the builds that are currently happening. Then there's also some third-party build bots for out-of-tree projects, for downstream tool chains, for other software builds that use LLVM. One notable example here is Green Dragon, which is the Apple system for hosting LLVM build bots. There's also a lot of different build bots in there, but it's not connected to GitHub. So you will either get an email or an angry comment on your pull request if something goes wrong. Yep. So how should I actually test my patch? This may be quite obvious, but always testing locally before you commit something is definitely sensible. So with LLVM, just run ninja check or ninja check some sub project, or with make, it also works. If applicable, add a lot of your own tests. That should also be clear, but it does avoid surprises later if you catch all of your issues early. Yep. Then the question kind of is, does your patch affect how LLVM is built on different targets? And if this is the case, then you may have to cross-compile and see if it actually works for the targets that you want to support or that you change something for with your patch. However, if you also touch any of the runtime components and you need to execute the code that your Clang compiles, then you should also include emulating the tests on the target machine or testing on the target machine you're building for. However, if your patch is, for example, only working on CodeGen or something, then it may be sufficient to just run your test suite on the default host target build. Just remember to enable all the relevant targets in CMake so that you actually test for them. Okay, now to some basics regarding cross-compilation. So what is really nice in Clang is that Clang is a native cross-compiler, meaning you can compile for any target system basically that's supported by LLVM, which is quite different to GCC, where we basically have a whole GCC installation for every target you need to you want to generate code for. And a central, let's say, feature here is the so-called target triple, which tells the compiler what kind of code it's supposed to emit. And we have different substrings in there. Starts out with the ISA, so for example x86 64. Then in some arcs you have also some sub architecture for ARM, for example. You have a lot of those. Then there's the vendor, which can be PC, Apple, NVIDIA. For the vendor, a lot of times it's just set as unknown, and then we'll just assume some defaults. Sys is your operating system, and then in the end some environment relating to API in object file format. So for my laptop, which is running Linux, this is the full triple is this. So x86 64 PC Linux GNU. So the compiler doesn't work fully, let's say, like isolated, but it relies on a variety of supporting tools and libraries. And this is called the compiler toolchain, or just a toolchain. The toolchain is made out of the assembler, linker, object file utils, and a bunch of stuff that's just needed to link and run your binaries. And we need the target toolchain to actually create an executable binary for the target code we're trying to compile for. The default toolchain for most Linux systems is based on GNU components, so GCC, bin utils, and libc. For a lot of those things, LLVM provides replacements. Let's say for the linker and a lot of stuff. I'll have another slide there. But the default for Clang, and that's maybe good to know, is the GNU version for a lot of these tools. Here's a handy overview of the components in Clang LLVM and the corresponding GNU components. So for most things, for the assembler, for the linker, for the runtime library, you have a Clang equivalent for the GNU part. Basically, only the C library is something that you have to use libc from GNU if you compile on Linux. Oh, and by the way, this is from a talk from FOSDEM 2018. I can recommend that if you want to look further into cross-compilation. Yes? Yeah, sure, go ahead. I have no idea on that. Cool. To actually set these parameters to tell LLVM and Clang about these components, you first, you can force LLVM or tell Clang to use the LLVM components. This is, for example, the runtime with RTLib, the C++ standard lib. You can use libc++ instead of the GNU variant, and use, for example, LLD as the linker. Then for GCC-based toolchains, to actually pass the parameters needed, you can just set --GCC toolchain and then path to your GCC installation, and that will tell Clang to use this toolchain for everything that's not specified by flags like that at the top. And sysroot is basically the libc installations and libraries that depend on libc. Then also if you rely on runtime libraries, for example, if you work on compiler RG, then there's a resource directory in Clang. You can get that by executing this command. And so if you have target specific shared libraries, for example, you need to put them in there for the target you want to build for. Cool. So now we know how to, yes? No problem. Yep. Okay. I haven't used it. I don't know what that option does, I think. Yeah. Mhm. Yeah, I think that may be the default. Yeah, yeah. I didn't know about that parameter, but I think that's how it looked for my installations. So yeah. So now we talked about how to use a toolchain, how to actually set up toolchain though. So well, of course, if you have your target system somewhere, for example, you're working on embedded and you want to compile for the system but can't compile on the system because of resource limitations, then you can just copy the toolchain files from that system. But in most cases, and if you're using it cross-compilation for the purpose of testing, you most likely don't have the toolchain available. But luckily there is different platforms where you can download precompiled GCC toolchain binaries. And I've used these two resources before, which is firstly Naro. They have toolchains for ARM and ARM64, and also Bootlin. They have a wider variety of targets for ARM, PowerPC, MIPS, a lot of them. I've used them both and they both work fine, so can recommend. Cool. And to kind of put it together, if you have the toolchain and the first thing you could do is cross-compile Clang, for example. These are the CMake flags that you would have to set to do that. So you set the host triple, the targets to build, of course, has to include the target. Then it always makes sense to set the install prefix because you don't want to accidentally install some other target binaries in your native folders. And then you add the target flags that you need to the CXX flags. I'm actually not sure if you also need to add it to C flags. says no in the, or at least it doesn't mention the C flags in the tutorial. But I think, yeah, it worked like that for me. So again, you set target, the sysroot, and the GCC toolchain parameters. You can also add any architecture flags to optimize for a specific architecture, using mark, for example. And sometimes if you have a more exotic toolchain, then you may have to include some more paths and libraries. Cool. Then one thing I encountered during my journey was Apple-specific build failures, because the CMake I was working on had some different cases for Apple and Linux builds. So of course the easiest option here, and the one I would recommend, if you have access to Apple hardware, then just build on the Apple hardware, and it's easier. However, you can actually build for Apple targets on Linux. And there's this handy project called OSX Cross, which basically helps you build a proper cross compiler for Apple. In order to use that, you should download that. And then you also need Xcode, which is a bit annoying to get actually, but after registering with Apple and, I don't know, jumping through some hoops, you can actually download and extract the SDK. And then using that, you can build OSX Cross, which will then generate compiler wrappers that you can just use to cross-compile. So it's pretty cool. So for each target, you get something like this, where you have the target and then your specific Darwin version you got the SDK for. And then you can use this to build Clang LLVM sub-projects or anything else. Cool. So now we learned how to cross-compile, but like I said before, if you actually need to test your code, need to run the code that you that you cross-compiled, you have two options. Either you run it on your on the actual target system, or you emulate. And I found, well, for emulation, Cameo is a very good project. Makes it very easy, much easier than I thought it would be. This is a project based on the kernel virtual machine in Linux, which is pretty fast, reaches near native speeds. And the kind of killer feature for me at least, for the purpose of testing LLVM is you can use user mode emulation, which allows you to run the target code on your system without having to set up the whole OS and everything. So yeah, it's available on all the distros, and basic usage is just this Cameo minus, let's say, arc64. Then you add your sysroot and just your cross-compiled binary, and just running that, for me at least, always worked out of the box. So pretty cool. Was much easier than I thought it would be. Cool. Then some final thoughts on putting it all together. So this is what I did for testing my compiler RT extension. Basically, yeah, first step, get the toolchain. I think in my case I got from Linaro. Then cross-compile compiler RT, so I have a different build for your target libraries there. I added all the flags here. I don't think I need to go over them, but just basically again, set your toolchain, set the sysroot, and then once that's built, you need to make sure that the target-specific libraries are in the resource tier. Yes. That is the target toolchain, yes. So this is it's not written here, but these flags are like compiler RT specific, just to make it easier to cross-compile and emulate, because that's a common workflow for it. Yes, so if you just have, for example, one test that fails, then you can also just copy the compile command, add the targets, this root, and toolchain flags, and compile the individual tests, and then run it with Camu. However, compiler team makes it quite easy to run the whole test suite. So you have this RT emulator flag where you can put an emulator, and this RT test compiler C flags flag that allows you to put all that in there, and then compiler T will automatically test all the run the whole test suite using your target and the emulator. So just running in the check in the end will run the test suite for your desired target system. And then hopefully this is the result. Happy buildbots. Thank you very much. Yeah.
I have a couple of questions. First of all, you mentioned that you can download the non-native chain on Linaro.
Mm-hmm. Yeah, it's just basically a zip folder. Oh yeah, yes, of course. So the question is, what do you actually download when you want to get the toolchain from Linaro, for example? And the answer is it's basically a zip file containing the GCC installation with all the libraries and dependent tools that you would need for building and executing your binary.
Maybe another question.
Mm-hmm. So, well, yes, of course. Question was, is there some resource that tells you what you need to specify, if that's for the target triple? So the target triple depends on the system that you want to compile for. So I'm not sure if you can.
Where did you get?
Well, in my case, I looked at what the buildbots were building on, and then just copied that or made some slight adjustments, and then used that target triple. I'm not sure if there's a full, like, of course Clang supports some and not other targets. It's also a bit not fully like specified what each parameter means. So you can like combine very strange. You can have weird combinations of these targets in principle, and I don't know. Sometimes Clang might complain, sometimes not. But in the end, I would just look at what people are testing for and then use that.
If in that specific case for LLVM, if you have unhappy buildbots, another option is just ask what is the target triple that I need to use in order to like do what you do. Because one of the things that buildbot maintainers are asked to do is either reproduce the issue or work with the contributor to like let them reproduce the issue. So
it's maybe it's a sidetrack, but I found it quite unintuitive to go to the buildbot side and figure out who's doing what in order.
If you click on the worker from the buildbot view, we can take a look at from the buildbot view. You can click on the worker where this is running. Then the worker has an email address to the maintainer of that thing. Okay. So you can click on that and send an email.
So there's always email going around.
There's email going around. Like, I don't know what the hell is going on here.
Maybe a final question.
Mm-hmm.
You mentioned which is the guide from Clang, I guess.
Mm-hmm.
How complete is that when you consider your work here for this patch now?
Okay, so the question was how complete is the Clang LLVM guide for cross-compiling? I would say the things that are described there work, but usually it's a quite narrow test case. And if there's things like, okay, now I cross-compiled, how do I actually run this code? Like, how do I emulate? Then you have to find the right place where that is outlined. Also, some of the flags for, let's say, compiler RT specifically are kind of buried. So there's another like README somewhere in the documents that tells you, okay, there's this emulator flag that you can use. But if you don't know about it, they don't, like, it's not very apparent. So like with a lot of things, you have to dig a bit sometimes. Yep.
Describe what you should be doing for like testing and contribution. Would you actually recommend that to do that as the first step of the contribution? Because to me, it feels like a huge.
Yeah, I mean, for me, I think I didn't do all of that. Oh, sorry, repeating the question. So would I recommend using these all of these testing steps for when you prepare maybe your first patch? And I think for me the answer would be, if I could go back, I would probably do all that from the beginning, because it's kind of a hassle to, well, uh, once there's stuff failing, then you have to revert. It's a bit, awkward. It's not a huge deal to revert and resubmit. But I would say if you need, like, if you know you need cross-compiling in the end to properly check, then I would say it's worth to do before finally submitting a patch. Yeah, I think that would be my answer.
In my opinion, check is fine. Also against that, contribution should not involve before you even submit the patch to do cross-compilation.
Yeah, it's fair enough. I think for me, like, another aspect is that to actually debug the issue. So the fix in my case was very easy. It was just like something I overlooked. But then, so I didn't want to resubmit without knowing, okay, this is actually fixing my issue. So, yeah,
That would make sense when the buildbots fail.
yeah,
If you have to be
yeah. Yeah, that's fair enough. I should mention for anybody looking to contribute, it's it's different in different projects, but for Clang LLVM, it's a normal, like, workflow that things may fail and you may have to revert a commit, and it's not the end of the world. Yeah, I think that I should mention that.
So I think for the first contributor, I would actually agree with you that you should not like have it as your, oh, I need to cross-compile for every like weird lips that someone is running.
Yeah.
Also, I don't know. Something that failed on a specific architecture and you have follow-up things, then I think it makes sense to put the burden on myself to first, okay, let's do cross-compilation because I know I messed around and compiled RT and like failed on some weird architecture. Let's make sure that this doesn't happen because I have already the setup to do that, right? I did already do the first contributions. I know how to do this. It's as easy as, was described in the talk, but because I already have the setup. And I know it may run into like issues again. But I would agree that for a first time contributor, like F it.
Hmm. Cool. Then, okay, one more question.
Helpful are these like buildbot log files, comments, and like all the stuff that buildbots do, and potentially like send you 10 emails for like all the different buildbots that fail. Like how reasonable is that?
So the question was, how reasonable and helpful is the information you get by buildbots via email and on your pull request? And I have to say, I mean, it's definitely very helpful to be able to look into all the logs and see, okay, this test failed on this specific target. I think that's a great thing that there's so much testing that's like publicly available to look into. What can be annoying is that out of the, I don't know, 100 and something buildbots on the main buildbot farm, there's always 5, maybe 10 that are failing for other reasons. Could be because somebody else's patch before your patch was broken, or could be because the bot itself has some kind of timeout or something. So in order to get to the issue that's affecting you, you kind of need to filter through all the noise. So that can be a bit annoying. But I'm not sure on how that could be improved so much. Yeah.
For figuring out a reasonably similar build config that paired on buildbots, is that, you know, I mean, I know that you can, like, you would typically, like, go to the buildbot page, click on the CMake line, scroll all the way up.
Yep.
Potentially, like, copy the CMake config or at least some flags, and then put that into your CMake. That's kind of annoying, right? For the cross-compilation, however, I would imagine that that doesn't necessarily translate one-to-one between the CMake config on the bot and your local CMake config when doing cross-compilation.
Yeah.
How did you, like, do this mapping, or how tedious was it to actually find out, like, oh, what's a CMake config that reproduces the issue
Mm-hmm.
in this cross-compilation scenario?
Okay, so the question was how difficult or how annoying was it to kind of extract the information about how to reproduce that build locally from filtering all of the information that you need to build LLVM that way, like the buildbot does. And so I simply started with like looking at the target triple only, and maybe browsing all of the other CMake options. But I just tested out. Okay, if I only take this triple and use cross-compilation to test for that, does that produce the same error? And in my case, I think it always did. So I just assumed that there's no other parameter that would affect that, which is of course not guaranteed. There could be some other things involved. But for me, that system kind of worked. Yep. I think so. Question was how long did it take me to set everything up and test and prepare a patch after the initial failure? I think it was maybe a week or something, but not for work. It was like looking into documentation, yeah, writing the actual patch. Yeah, I would say about a week from the initial failure to the patch being accepted.
What actually was the issue?
So question was, what was the issue? So there were 2 issues. I think one was just related to the CMake, because there's like different libraries involved, like shared libraries involved for building X-ray. There's like different cases for Apple and for Linux. So there was some kind of issue with that, that some libraries couldn't be found properly because I don't fully remember. And then I think on ARM there might have been some linking issue. I couldn't tell you fully, to be honest. It's been a while. Yes. Mm-hmm. Mm-hmm. So question was there any support by the people that reported the failures on the PR and per email? And I have to say, not really. So it was mostly just so this failed on this and this buildbots. Please respond. We'll revert it for now, basically. Not in any rude manner, but yeah, I think the issue is that a lot of these maintainers have a lot on the plate, so it's yeah, hard to properly give like instruction on how to what to do step by step. So yeah, I think it would be good for Clang LLVM for the project to have better documentation on what to actually do in that case. I mean, there's information out there, but it's, yeah, you have to look for it.
And I think we can thank the speaker again.
Thanks.